Hi all, welcome to Distributed Computing video lecture 2. So in the previous session we discussed about what a distributed system is, what are the different characteristics of a distributed system, and we have seen few examples of distributed systems. So in this video session we are going to discuss about issues or challenges in designing such a system. Okay, so as we have seen, a distributed system is one in which there will be n number of systems, they'll be connected together and they'll be performing a particular task. So please be careful about the term. We are interconnecting different systems in order to perform a particular task. So while connecting such a system or while connecting such systems in order to build a distributed system, we may be facing different issues or challenges, and they are enlisted here. They are heterogeneity, openness, security, scalability, failure handling, concurrency, and transparency. So there can be issues related to heterogeneity, there can be issues related to openness, security, scalability, failure handling, concurrency, or transparency. So let us explain each one in detail. The first one is heterogeneity. Listen, see, as we are connecting different systems together, there can be differences between these systems, right? There can be incompatibility, there can be compatibility issues in terms of networks or computer hardware or operating systems, in programming languages or in various implementation aspects. They may differ. So the systems may differ in different aspects, they can be heterogeneous, and this can be a problem while connecting systems together. So the internet enables users to access services and run applications or heterogeneous collection of computers and networks. We are implementing internet in this manner. As we already seen, internet is an example of a distributed system, and in such a case, actually, we are connecting heterogeneous collection of systems together in order to perform tasks. So heterogeneity actually means it applies to all of the following, like networks, computer hardware, operating system, programming language, or implementation by different developers. Each systems may differ in all these aspects. So while we are connecting systems together, heterogeneity can be an issue. Okay, so while connecting systems, we need to handle this, or we need to overcome the differences. That is why we are using middlewares. So middleware is actually, it acts as a translator between two systems. Okay, they mask the difference, they helps to communicate smoothly. So the term middleware applies to a software layer that provides a programming abstraction as well as masking the heterogeneity. Also, there are certain situations in which we can trust upon some mobile codes you might have heard about, or you may be familiar with the Java applets and all, right? So there are certain situations we may be depending on such things also. The term mobile code is used to refer to a program code that can be transferred from one computer to another and run at destination. So Java applets are an example. Code suitable for running on one computer is not necessarily suitable for running on another, because executable programs are normally specific both to the instruction set and to the hosting operating system. So in a general idea, we can say that yes, middlewares helps to avoid this problem, or helps to improve, or helps to mask the heterogeneity of those systems. Okay, so that is why heterogeneity aspect is important. So this is the first challenge or issue. Second one is openness. What is openness? Openness means it actually determines whether the system can be extended or re-implemented in various ways. See, we are adding n number of systems to this distributed system, right? So the overall system must be always expandable, right? Or it should be re-implemented. It is the important aspect. So the characteristic that determines whether the system can be extended and re-implemented in various ways, that is what openness means. So the openness of distributed system is determined primarily by the degree to which new resource sharing services can be added and be made available for use by a variety of client programs. In order to achieve this, we need the following. Like, open systems are characterized by the fact that the key interfaces are published. Open distributed systems are based on the provision of a uniform communication mechanism and published interfaces to access to shared resources. An open distributed system can be constructed from heterogeneous hardware and software, possibly from different vendors. So that is why openness is an important aspect. Okay. Third one is security. See, as we already know, security in terms of confidentiality, integrity, and availability must be ensured while implementing a distributed system. Confidentiality in the sense protection against disclosure to unauthorized individuals. Integrity means protection against alteration or corruption. Availability means protection against interference with the means to access the resources. Okay, so however, security challenges have not yet been fully met for denial of service attacks and security of mobile code. See, we are actually facing many issues while implementing such a security distributed system in terms of security aspects. So the thing must be ensured, like security in terms of confidentiality, integrity, and availability is to be ensured while implementing a distributed system. And next one is scalability. Okay, scalability means distributed systems operate effectively and efficiently at many different scales, ranging from a small intranet to internet. A system is described as scalable if it will remain effective when there is a significant increase in the number of resources and number of users. Even if we are adding more systems, even if we are adding more users, it should be capable of performing. The number of computers and servers in the internet has increased dramatically, so that's why scalability is an important aspect. So the design of scalable distributed systems presents the following challenges, like controlling cost of physical resources, controlling performance loss, preventing software resources running out, and avoiding performance bottlenecks. So these are the different aspects of scalability, and scalability is an important issue to be addressed while implementing a distributed system. Next one is failure handling. We have already discussed it as an important aspect of, or as a characteristic of, a distributed system. But the failure handling thing, failures must be addressed and they must be detected or masked, or they should be handled properly, right? So computer systems sometimes fail. When faults occur in hardware or software, programs may produce incorrect results or may stop before they have completed the intended computation. Failures in a distributed system are partial, that is, some components fail while others continue to function. That is an important characteristic of a distributed system. So the handling of failures is particularly difficult, and we can go for detecting failures, like some failures can be detected, or masking failures. See, at times we may need to hide those failures, like see, you have you're knowing about these things, that is, messages can be retransmitted when they fail to arrive. So this is actually a masking of failure. File data can be written to a pair of disks, so that if one is corrupted, the other may still be correct. That is, we are actually taking a backup. These kind of things can be done in order to mask failures. Also, at times we may be tolerating failures. That is, most of the services in the internet do exhibit failures. It will not be practical for them to attempt to detect and hide all the failures that might occur in such a large network with so many components. So when a web browser cannot contact with its web server, it does not make the user wait forever, right? While it keeps on trying, it informs the user about the problem and leaving them free to try again later. So that is actually kind of tolerating failure. Okay. And also there are situations in which recovery from failures to be done. That is, recovery involves the design of software so that the state of permanent data can be recovered or rolled back from a server has crashed. So handling failures in a distributed system is a major aspect. Next one is concurrency. See, concurrency, we have already discussed this one as a characteristic of a distributed system. That is, each devices can be, they can perform at the same time. So, and this is to be addressed or addressed in a proper way. Both services and applications provide resources that can be shared by clients in a distributed system. There's therefore a possibility that several clients will attempt to access a shared resource at the same time. That can be, see, in the case of operating system, you might have heard about mutual exclusion, right? So the same thing can happen in the case of a distributed system scenario also. So those things must be addressed while we are having this concurrent action of different devices. So that is an important aspect. And the last one, transparency, and this is also an important aspect of distributed system. So transparency is defined as the concealment from the user and the application programmer of the separation of components in a distributed system, so that the system is perceived as a whole rather than as a collection of independent components. In simple terms, the user who is using this distributed system, he is not at all aware about the fact that, okay, these are the connected systems, or this is not a single system, these are the collection of different systems. The name user is not at all aware about this fact, right? So that is what transparency means. And this concealment of all these aspects are there in different, we can say that different levels are there. Like access transparency is there, location transparency is there, concurrency transparency is there, replication, failure, mobility, and performance transparencies are there. So access transparency in the sense, it enables local and remote resources to be accessed using identical operations. See, for a simple example, you are accessing a particular file from a folder which is located in a different system, but you are feeling like, yeah, it is there in your system. See, that is what access transparency is. Even if a particular system is there, or even if it is saved somewhere else, but we are feeling like, yes, it is there in your system. That is what access transparency is. So similar thing is there in location transparency. That is, it enables resource to be accessed without knowledge of their physical or network location. We need not to bother about where it is actually located. Concurrency transparency means it enables several processes to operate concurrently using shared resources without interference between them, and we need not to know about whether they are simultaneously working or not. So concealment of all these ideas are there. Replication transparency, we may not be, it actually conceals the fact that there can be multiple copies. So enable multiple instances of resources to be used to increase reliability and performance without knowledge of the replicas by user or application programmer. Failure transparency. Failure transparency means it enables concealments of faults. Mobility transparency means it actually hides the fact of whether it is in a moving state. That is, see, it allows the movement of resources and it won't be affecting the user, right? That is what mobility transparency is. Performance transparency means it allows the system to be reconfigured to improve performance as loads vary, but that won't affect the user. So concealment of all these ideas means concealment, transparency. Transparency means concealment of replication related, failure related, mobility, performance, location, access. All these ideas are concealed, and we are feeling like, yes, everything is there in your system. We are having that feeling. So that is what transparency means. And the first two things, access and location transparency, are most important aspects, and they are referred together as network transparency. Okay, so these are the different issues or challenges while implementing a distributed system. So these 7 aspects are very important. So hope you all are clear about the ideas. Thank you all.